graphs and functions, okay? You guys know what relations are. You know whether a relation is a function or not. That question was quite good on the test, but I'll leave it at that because not everybody's written it yet. So we've been talking about what functions are. We've been talking about properties of functions like domain and range, okay? And we've looked at functions and relations in different forms. Like you could be given a set of ordered pairs and asked to find the domain and range and state whether or not it's a function. You could be given a graph, or sorry, not a graph, a table or an arrow diagram. We've done a few graphs, but we're going to focus on more graphs now and all sorts of different types of graphs. Graphs that just have points on them, graphs that have curves on them or lines on them. Because we have to be careful how we find the domain and range of some of these. So this is really just review, the first couple questions. So here we have a couple relations, R1 and R2, that are represented by a set of coordinates. So for each one, we want to write whether it's a function or not, and then the domain and range. So we should know R1. Is it a function?
Yes.
Yes, it is. What is the domain?
1, 2, 3.
Graces. What is the range?
4, 6, 8.
Good. How about R2?
No.
Not a function. Why?
Domain.
Yeah, one of the domain values repeats, the 1. What is the domain?
1 and 3.
Right, do not write the 1 twice. What is the range? 4, 6, 8 again. Yeah, so really, this would have been like questions on your test. So when we've got a set of ordered pairs, you guys know what to do for domain, for range, and state whether or not it's a function. Okay. You guys are also familiar with what to do if it's an arrow diagram. 3 things. Is this a function? Yes or no? Why? The domain repeats -4 because it's got 2 arrows coming out of it. Excellent. Not a function. What's the domain? -2, -4, -6. Yep. And what's the range? 0, 4, 8. Okay. Good. Again, review. Something that we haven't really looked at a lot, and we're going to focus on in this lesson, is graphs. All right. We got all sorts of different types of graphs. We can do a series of points like the first one. We could do a line segment. We could put arrows on the end and make them lines. We could have curves that have arrows on them, all sorts. We could have shapes like circles and squares, all sorts of shapes we can put on graphs. You need to be able to find the domain and range of each and whether it's a function or not. Let's look at the first one. Is that a function? Why? Because which repeats? At where? X equals Like, what's the x coordinate here?
Negative one.
Yeah, don't say, I don't know, you know.
0, 1.
So 1, 1 appeared twice, right?
No.
It didn't?
What?
Not a function. So when you see a series of points, think of it in ordered pairs. So just go through all the x's, and if one repeats, it's not a function. And to write the domain, go through all the x's. What were all the x's we listed? -1, 0, 1, and 2. The range is all the y values. Yeah, here, y value is 1, y value is 1, y value is 2, y value is 3, y value is 4. So 1, 2, 3, 4. So when it's a series of points, it's pretty straightforward. Okay. Okay. The next one. Yeah. Did you just go like this to me? No, you said 4-6 because you went like that. See, and 4 again. You keep waiting. Now it's 5. Pencil. Is it a pen? Ask your question. Why are you stalling?
-1 and 1. You said those 2 ones on the x wasn't straight line.
There are 2 points where x is 1 on this graph.
Oh, and then you put it 4.
I think you're confusing domain and range values.
No, I was confused because I was looking at the domain and I thought for a second you didn't know.
Well, the range repeats. There's 2 1s for the range.
You waited twice.
That's right, you don't.
That's why I was confused.
Kate,
Is this going to be our last minute for the exam?
no. We've got trig to do.
Is that 5?
You don't even, is that high?
Hi. She's doing it cold.
High?
Hi.
Sorry. Oh my God, ew.
Hi.
Come on. Anyway, I'm going to ignore you guys now. And before we answer whether this one's a function or not, let's do the domain. How many points are on this graph?
6.
Really?
5.
Really?
3. Wait, 4.
Really? 4?
5.
5?
Oh, wait.
There's a-
This one. Oh, sorry.
There's a point here, right?
Yeah.
There's a point here. There's a point here. 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 How many points? Infinity. Infinite number of points. But what's the point that has the lowest x value? Isn't it the point to the furthest left?
Yes.
Which is what? So -3 is the lowest x value we're going to see. What's the highest x value we're going to see? 4. And everything in between.
Oh, she has to write like
So you have to write it like?
oh, which one? Hold on. If they will be over.
Interval notation or set notation. Let's do interval.
What is it?
It's not going away. What's the domain? We said the furthest left was -3. The furthest right was 4. Do we include the -3 and 4? Yes, so we put brackets. That's the domain. No braces. We only do braces when there's points. Whenever there's line segments or lines or curves, we have to use interval or set notation. Lowest to highest. Yes.
So just square line, the square line is being included, right?
Yes.
Oh, I was confused. I thought it was the other way around.
How do you write this using set notation?
Yeah.
Less than or equal to. Good. So now we're going to encounter domain and range where we have to use interval and set notation. What I always do interval first and then I convert it to set. Okay. And we're actually going to focus on interval notation in grade 11 and grade 12. Okay. Generally, it seems to be easier to use in general. Those are called inequality signs. Anyway, the range. Now range is y values. Where is the y value? Or sorry, where is the point with the lowest y value? -2. Where is the point with the highest y value? +2. And because they're connected, everything in between. So the range goes from -2 to +2. How do you write that? Oh, you're going to make a mistake. You're going to make a mistake because it's not this. Oh, sorry. It should be 2. Yes. Remember, domain is y values. Oh yeah, everything's still the same, except because we're talking about range, we use y instead of x. Because we want to tell the difference between these two. When you see x in set notation, that's domain. When you see y, that's range. Okay? Now, is it a function or not? Yeah, is it possible for any x values to repeat? No. Don't they have to be vertical in order to repeat? Just like we saw here. So there's actually a really easy way to tell if a graph is a function or not. It's called the vertical line test. If you can draw a vertical line through more than one point on the graph, not a function. The next one will not be. So the vertical line test if you can draw a vertical line through more than one point on the graph, that means a domain value repeats. That means it's not a function. It is not a function. If you can draw a vertical, through then one point. Oh, me speak good English. Vertical line test. If you can draw a vertical line through more. Yeah, I know, eh? You. Come on. It is not a function. And that applies, it doesn't matter whether it's a segment, a curve, or a series of points. Like here, I could draw a vertical line. Oh, stop it. Oh yeah, look out the window when I look over there, like it wasn't you. I can draw a vertical line through those 2 points. That means not a function. Okay. Thank you. There's no way I can draw a vertical line through this and hit more than 1 point. So it is a function.
Oh, in my brain, if there was a vertical line, it was a function. That's why I got the last time. But I just got the B.
There you go.
So I was like
Okay. All right, let's look at the third one.
Is a function or is not a function?
It's not a function, so we got that, because I can draw a vertical line through like here, I could draw it here, I could draw it here, I could draw a whole bunch of them. So not a function. Not a function. But just because it's not a function doesn't mean that we can't find the domain and range. Ooh, what's the domain?
Is it negative infinity?
Not quite.
Well, because it keeps going because there's arrows.
You've got the first half right. You're right. Like what's the point to the furthest left on this graph? Who knows? Because it goes on forever. So it's negative infinity. But it goes all the way up to and stops here at 0. So it goes from negative infinity to 0. Negative infinity to 0, and we include 0, so we put a bracket.
And then that.
Who said wow?
No, see what
How do I write this using set notation?
X is the next step.
Oh, look at you. Now, what's the range? Remember, range is lowest point to highest. Negative infinity to infinity.
Oh my God.
Because, well, look at this. Not only does this go to the left, it keeps going down forever. And not only does this go to the left, it keeps going up forever. So therefore, the range is everything. Oh. In interval notation, it's negative infinity to positive infinity. What is it in set notation? So we got two people that are right here. Those that said XER, and then the one that corrected to say it's Y. Well done. Yeah. For the range or for the domain? Well, it goes to the left forever, right? So that means where is the furthest point to the left? What's the X value of the point to the furthest left? Well, if it goes forever, it's negative infinity. What's the X value of the point to the furthest right? It's right here, the point 0, 0. No. That makes sense? Why don't you write it down? Okay, a little bit more practice. You guys are doing well with this. Okay, so here we have a couple of graphs with points. So they're not connected, so we're not using the interval notation stuff. We're using the braces. Right away, as soon as you see points, you should think, okay, braces. But actually, we aren't asked to find the domain and range anyway. All we are asked is whether they are a function or not. Why is the first one not? Yeah, like you could say it different ways. You could say the domain value repeats at 9 and 8.5. If you said that, that's perfectly correct. Or if you said, well, no, because we can draw a vertical line through more than one point. Vertical line. How about the second one? Yeah. Yes. And because we can't draw a vertical line. Just for fun, tell me the domain of this.
1960,
60, 70, 80, 90, 2000.
Okay, and what kind of symbols would you need around them? Braces, right? We only use the interval notation if it's curves or shapes or lines, like the second example or the next example. So here, we want to find the domain and range of each of these. We're not asked whether they're functions or not. Actually, they're both functions because I can't draw a vertical line through more than one point on each of them. Are you confusing vertical with horizontal? It can't draw a vertical line through more than one point on either of them. Yeah. Anyway, domain and range. Let's do it. So as soon as you see curves or lines or line segments, you got to think interval notation. So for the domain, it's furthest left to furthest right. Remember, not only does this go up forever, it's slowly pushing to the left forever. So it's negative infinity is the lowest with the parenthesis, and it goes all the way up to the furthest right with this x coordinate of 3, and we include it. How do I write that using set notation? You just saying random letters. How about range? What's the y value of the lowest point? I'll find the lowest point. Its y value is -1. And we include it, so we put a bracket. Infinity. Because, yeah, it stops here, but it still keeps going there. So it's infinity. So it's -1 to infinity. Y is greater than or equal to -1. All right, here we got a semicircle. They're connected. There's a curve, so I got to think interval notation. Domain, furthest left to furthest right. -2 to 2 with brackets. And that would be -2 less than or equal to x less than or equal to 2. The range, change your thinking, lowest to highest. And it's y values. 0 to 2 with brackets. And you guys are quite familiar with how to change that to set notation. Yeah, oops, sorry. Okay. This is actually a good question because it reviews some things. And you have to be able to read values on graphs. So, we've got number of fishing boats anchored in an inlet over a certain period of time. Okay. Function? Yes, it is. Why? Can't draw a vertical line. So, can't draw a vertical line through more than one point. We talked about this one before, and perhaps you remember this from science. Which variable is the independent variable and which one is the dependent? Time is independent because it's on the horizontal axis. Number of boats is dependent. So I'm just going to put IV for independent variable, time, and DV for dependent variable, number of boats, not hashtag of boats. It also means number. There's no such thing as hashtag when I was your age. It was just called number. We had to get up and change the channel on the TV. We didn't have a remote. Had to walk 20 miles to school every day. 10 feet of snow, uphill both ways. Write the domain and range. Okay, what's the domain? So you got to be able to read these. So what's it going up by? First of all, so it's going up by, no, the independent. We're going up by, so here's 9 o'clock. 10, 11, 12, 13, 14, 15, 16, 17. So it's going up by 1 or 1 hour. So there's one at 10, there's one at 11, 12, 13, 14, 15, 16. Not one at, oh yes, there is one at 9. So 0, 900, 10, 11, 12, 1, 13, sorry, because we're on 24-hour time. 14, 15, 16.
So then the second one's going up by 2.
Okay, so what are all the Y values? Yeah, it's going up by 2s. No. I want to know the Y values of the points. So these two are 6, then 8, then 10, then 11, because it has to be a whole number because it's number of votes. 15. Should be 25. So yes, 6, 8, 10, 11. 6, 8, 10, 11, 15, 25. Yeah. Good. And I'll move this up a bit so you can see it. Always. Yeah. Like when you're given a graph, the domain is always the x-axis, horizontal. Okay? If you're given a table, the domain is always the first column. If you're given a set of ordered pairs, the domain is always the first number in each pair. That's how you can recognize it. Okay, here, this is kind of a little bit of a different question. Remember, domain means what? X. Range means what? And this is function notation. Remember, f of x, we can also write this. It means the same thing. So this stuff here is a fancy way of answering something a little bit easier. So given this function, think y equals negative 3x plus 7. Find the y value when x is negative 2. That means go to the point where x is negative 2. Where is the point where x is negative 2? Here. And then I got to go up. It's here, isn't it? Yeah, what's the y value there? Yeah, it looks like it's 13. So by the graph, y equals 13. However, we can also find it by algebra. How do you find it by algebra? Plug -2 into here. So y equals -3. We're told that x is -2 times -2 plus 7, which is 13. Same thing. Algebra and graphing are connected. Big time. Just one thing I want you to remember out of high school math, it's that algebra and graphing are connected. You can solve any equation by algebra, which you guys do, but you can solve any equation by graphing. So for B, we're asked, determine the domain value or x value when the range value or y value is 4. So where is the y value 4? What point? This one, isn't it? This has a y value of 4. What's the x value? Oh, come on. 1. Don't overthink. So by the graph, x equals 1. We could also do it by algebra. Go to the equation you're given. Y equals -3x plus 7. Remember, f of x and y mean the same thing. This time you're given y, you're told that y is 4, and you have to figure out what x is. We'll solve that equation. Subtract 7 from both sides, and you get -3 equals -3x. Divide both sides by -3, and you get x is equal to 1, which makes sense. Okay. But the big thing I want you to get out of this one is how to find the domain and range of all sorts of graphs now. Whether it's points where we use braces, or whether it's connected curves, lines, line segments, where we use interval and set notation. Okay.